Let's calculate the indefinite integral of t squared e to the 3t dt. So, first thing I'm going to do is I'm going to write this as t squared e to the negative 3t dt. And now I have a situation where I have an integral that looks like it's for two functions that are multiplying each other. So that's kind of a hint that we should use integration by parts. But more importantly, the next integration, if I do integration by parts, will involve a derivative of one of these. And the derivative of t squared is 2t, which will be a little bit of an easier integration to do. So I think I'll commit to doing integration by parts here. The choice of u and dv by dt is as follows. U should be easy to differentiate, both of these are. dv by dt should be easy to integrate, both of these are. But to break the tie, I should choose u so that when I take its derivative, it actually makes the next integral easier. So if I take the derivative of e to the negative 3t, that's going to be negative 3e to the negative 3t, and that doesn't appear to be any easier. But the derivative of t squared is 2t, so that's a lower degree than t squared, so I think I'll just try this for u. So I'm going to let u be t squared, and I'm going to let e to the negative 3t be dv by dt. So this allows me to now go, and I'll do my chart. U is equal to t squared, which means the u by dt is equal to 2t. V I'm not sure yet, but I know dv by dt is equal to e to the negative 3t. So now, to get v, I just do the antiderivative of this, which is negative 1/3 e to the negative 3t. And now I'm in a situation where I can do my integration by parts formula. So u times v is t squared times negative 1/3 e to the negative 3t. Okay, that's u times v. The rest of the formula says I should take minus the integral of v, which is negative 1/3 e to the negative 3t, times du by dt, which is right here. So times 2t. And of course, I should close the integration with dt. So if I just simplify this a little bit to make my life easier, I have 1/3, let's do negative 1/3 t squared e to the negative 3t, plus, I'm going to take this this 2 times negative 1/3 becomes negative 2/3, and I'm going to bring it out front, so that becomes plus 2/3. The integral of t times e to the negative 3t dt. So now, in order to finish this question, I just have to do this little integration here, which is I'm going to put in a box. This is the only piece that I have left to do. If I could figure out what this is, then I would just be able to calculate that and I'd be done. However, this actually looks like a fairly challenging integral to do, so perhaps I'm going to now have to go off and actually calculate this as kind of a side project. So I'm going to write this on a side. I'm just going to go off and I'm going to calculate this. Maybe draw a line here. I'm just going to do this calculation off to the side. So somewhere else I'm going to actually calculate just what this thing is in the box. So who cares where it came from? I don't really care. Let's just pretend we're starting a fresh new problem. The integral of t e to the negative 3t dt. So again, this kind of looks like an integration by parts question. You have two functions multiplying each other, but again, more importantly, is that integration by parts allows us to take the derivative of one of these. So I take the derivative of t, that just becomes 1, as long as we anti-differentiate the other. The next integration won't even have a t in it at all, so that seems like it would be much easier. So what I'm going to do is I'm going to choose this to be u. This is my u. This is my dv by dt. And now I can go over here and do all my pieces of my formula. U is equal to t, which means du by dt is equal to 1. V, I don't know yet. dv by dt is equal to e to the negative 3t, and the antiderivative of that is negative 1/3 e to the negative 3t. So now I can actually use the formula. U times v is t times negative 1/3 e to the negative 3t, that's e, negative 3t minus the integral of v, negative 1/3 e to the negative 3t, times du by dt, which in this case is just 1 dt. Let's simplify this up a little bit. This becomes negative 1/3 t e to the negative 3t. This negative 1/3 can come out front, becomes a plus 1/3, and the integral of e to the negative 3t dt. So now I'm in a position where I can actually calculate this integral here. It's just an antiderivative, and it's an antiderivative of something that I know. So that's negative 1/3 t e to the negative 3t plus 1/3, and then the antiderivative e to the negative 3t is negative 1/3 e to the negative 3t. And I'll just clean that up a little bit. Negative 1/3 t e to the negative 3t minus 1/9 e to the negative 3t. So this integral, t e to the negative 3t, is equal to this. So that allows me now to go back up into the original problem. The thing that was in the box I can replace by this. So this thing is going to go all the way up back into this box. So my final answer of what I'm looking for is negative 1/3 t squared e to the negative 3t plus 2/3. And now what was in this box? Negative 1/3 e t e to the negative 3t minus 1/9 e to the negative 3t. And of course, because it's an indefinite integral, I should put a constant on. And I can make my life easier. I can simplify this a little bit. I'm going to just simplify it just by doing something little. Of course, you could probably simplify it further, but I'm not going to. All I'm going to do is I'm going to multiply this 2/3 in everywhere. So this becomes negative 2/9 t e to the negative 3t. 2/3 times negative 1/9 is negative 2/27 e to the negative 3t plus my constant. And that is the solution.